Okay, so picking up right where we left off, we now need to add collision detection between the missiles and the enemies. What we're going to do is we're going to create a new prefab, and it's going to be a particle system. I'm not going to go into a full review of how to make the particle system, but I will give you the basics. I have a separate video series for that because particle systems are very complex. It's kind of like sculpting, and that is a lot of minute changes are made to get the effects that you want. But we'll go through the broad strokes. So click on Game Object and then Particle System. We're just going to rename it Burst. Going to click on Burst, and we're going to do a few things. We're going to change the shape from a cone to a circle. Since we're looking at the edge of the circle, we're going to rotate it towards the screen. We're going to change the duration of the sequence, well, of the particle system. We're going to change the lifetime of the individual particles, and these two do not have to match. So like a particle could last for a tenth of a second, but you want the entire particle system to run for maybe 5 minutes, or to keep looping infinitely. So they definitely do two entirely different functions. So start lifetime, reduce the speed, reduce the size, we'll shrink the radius, we'll increase the emission rate, we'll increase the max particle just to make sure it doesn't get exceeded, and let's see how that looks. So let's get rid of the looping, and let's move it over so the camera icon isn't blocking it. Definitely lasts too long, so let's try half a second. That's serviceable, just a simple little spark explosion. So we take that, we drag and drop it, and now it is in the assets area. So it is now a prefab, and we can destroy the original. So now what we need to do is we now need to modify the missile control script so that it checks for collisions with the enemy. Now, it should already be attached because we did it in the last video, but for some reason at some point I noticed my missile control script was no longer attached to the prefab. Should be for you, just double check. I think I might have accidentally removed it when I was testing a few things. So we're going to go into a missile control script, and this should be all that's in it. Is that in the update section, you're simply looking to destroy the missile if it goes too high in the screen. That's all we had done up to this point. So outside of start, outside of update, we're going to add this. Void on trigger enter 2D. This is case sensitive, so O, T, E, D all need to be capitalized. If there's any letter that's capitalized that shouldn't be, that will cause a problem as well. This is a pre-existing coroutine, needs to be exactly right or it'll fail. So on trigger enter 2D. Collider 2D, and it's colliding with an other object. So why are we using on trigger enter? Simple, because the missile object, as you recall, we set to a trigger. If it wasn't a trigger, then we'd be using on collision. So first, this routine says, okay, has a collision occurred? If so, then do the stuff that's in here. Now in this case, we're making another check before we do anything. If other .gameObject.name equals Jellyfish Clone, then destroy the game object that this script is attached to, which is the missile. So in other words, don't just go ahead and destroy the missile with any collision, because there's actually a collision occurring here. There's also a collision, I don't think the missile's colliding, yeah, the missile's not colliding at the ground, but the missile is definitely colliding with the base that's firing it. So you need to make sure that you're only having this occur if what it's colliding with is jellyfish. Now why Jellyfish Clone? Simple. even though this is the name of the object is jellyfish, when it is instantiated, you can see it appends the word clone. So if you don't do that here, this won't work. So you've got a couple things you can do. You can add a script to the jellyfish, which we probably will eventually, which renames the object. You do that in the start section. So in the start section, you just do GameObject.name equals jellyfish, and thereby renaming the object. You can do this, which we now demonstrated, or you can use a tag. So you don't have to use GameObject.name, you could use GameObject.tag, but then you have to make sure you manually enter all those tags in. So to me, it's probably just as easy to do this rather than start managing tabs, because the objects already have a name. And probably the most efficient thing to do is, like I said, you can rename the object when it gets instantiated, because say I have to check 20 different objects against collisions with a jellyfish, well, then I have to check for this every single time. So it might be easier just to rename the object itself. And we can examine how to do that. So we'll save that. And so yes, so if a collision with another object occurs, and that object is jellyfish, then destroy the missile. Let's see, so let's go to missile. Script is attached, so this should work. And it does. So now the missile gets destroyed. Now when the missile gets destroyed, we want to do a couple other things. We want to instantiate the explosion, and we want the monster to be destroyed as well, the enemy to destroy. So this is where we're going to create our next script. So right click, create C#, and we'll call this enemy control. Click on your jellyfish and drag and drop enemy control onto it. Go ahead and open that up. Now let's go ahead and do what we're just talking about. So at start, GameObject.name equals jellyfish. Now, as I said, the reason why you'd want to do this is because if you find yourself checking more and more objects, you have to make sure you append the word clone, and while it functions, it's also a little bit unwieldy to look at. So we can get rid of that. We save this, and now each object should get renamed to jellyfish. And it's important, unlike if statements, you're only using one equal sign here because you're not checking to see what it's equal to, you are changing it. So when we run it, you can see it now just says jellyfish, and the collision works. So just as we put in the collision for the missile, we need to put the collision in for the enemy. So again, outside of start and update, you need to do, actually let's just copy and paste because it's going to be very similar. So on trigger, enter 2D, collider 2D, other, but here rather than jellyfish, it's going to be missile. From the moment we'll have it say clone since we haven't updated the name there, and destroy game object. So effectively the same thing, we just have to make one change. The jellyfish, we originally did not set it up as a trigger. Go ahead and click on trigger, and that should now work. Yep, they both now disappear. Okay. Looks like they lost a line of code though, because okay, we didn't lose a line of code. What it is this needs to be put in here too. So we didn't lose a line of code, my apologies, we just didn't adjust for the destruction of the missile. So when the missile got destroyed here, we were reducing the static variable by 1. We didn't reduce the static variable by 1 here, so sorry, we didn't lose any code, we just didn't add it yet. There we go. 2 at a time. Excellent. So now what we need to do is we now need to have the particle system for the burst be instantiated. So you can either instantiate it at the missile, or you can instantiate it at the jellyfish, or if you wanted, you could have actually created 2 different particle systems and have the missile explode as well as the enemy explode. So, what we'll do is we'll go with the jellyfish. So enemy control, and we'll add a variable. So public transform, and we'll do this as burst obj. So now when we go to our jellyfish prefab, you can now see this is down here. So we'll just take that prefab, drag it onto it, and when this gets destroyed, we'll also instantiate that new burst object that we just created. Where we'll get instantiated, we'll instantiate it at transform.position, in other words, the position of whatever object the script is attached to, which happens to be the enemy, and we will use the burst object's rotation. That's about it. So a few more things, like if the enemy collides with the ground, do you lose? Enemy collisions don't do anything yet. I think I just actually I don't think I'll even bump into it because these are triggers now. Yeah. So nothing happens there yet. So we do have to clean that up, but otherwise it's functional. Could add a scoring system too if you wanted, but this really covers what I was looking to do, and that is do a thorough review of prefabs and a thorough review of instantiation, and to show the time saving and effort saving that prefabs do, as well as how essential they are, because as you can see, these enemies just keep going on and on and on, and I only had to write 4 lines of code to make it happen. And with those lines of code, you can also go put in randomization. Maybe they're staggered, maybe some are over here and then some are over here. So now that I think about it, let's go ahead and add one more type of prefab. It's going to be a particle system, but it'll be the enemy bullet. Up to this point, the particle systems are really just eye candy. They don't functionally do anything. So let's actually have a particle system be an object that can collide with other objects. So go to game object, go to particle system. We'll just call this bullet. We will change the shape again to a circle. We'll again rotate it towards the screen. We don't want it to be like a burst though, we want it to be more like a glow. So let's reduce that speed to like 0.2. Let's reduce that size to like 0.1. Let's move this over out of the way. Let's shrink this much smaller. We want it to have a very small origin since it's a bullet. We don't want it to be unwieldy big. Let's see. So now let's increase the emission. Now you're getting that ring in between because you have a max particle of 1,000 and emission rate of 300. Once you hit the max particles on the screen, it has to stop until some of the particles get destroyed. So let's go ahead and bump that up so that's not happening. Clearly that's too big. So lifetime, let's shrink down to 1. Okay, we're getting there. Not quite dense enough though, so let's bump that up to 400. Let's increase the size just slightly. And let's decrease the lifetime just a little bit more. Let's see how that looks. Okay. Let's make that pre-warmed. Let's also make it a little bit smaller. And a little bit denser. Do we want the size to be bigger? Now this is one of the things you're going to have to decide back and forth between size and rate, because you can make this more dense by increasing the particles, or you can make it more dense by well, should I say the rate of the particles. In other words, you're increasing the amount of particles, or you're increasing the size of the individual particles. They both give different effects, but they also create a more dense object. So that's one of the balancing decisions you have to make. See, very small difference made it much more dense now. So I think that's about what I want. Just tweak this a little bit more, make it a little bit smaller. Now what we need to do is we need to change the simulation space. Simulation space is local. So if you move it around, it's like it's a solid object. If you change simulation space to world, watch what happens. It now trails. So that's kind of what we want. Now sometimes you might not be able to get what you want just by doing that. You might actually need multiple particle systems linked together. So let's see how that looks. We're going to add, actually for the moment, even though I've shown it, let's go to local for the moment so it's easier to track where it is. We're going to go to add component, physics 2D, and we're going to go ahead and give it a circle collider. So that looks about right, but let's be a little bit more forgiving. So we'll do edit collider and shrink that in a little, because that's a little bit unforgiving. Let's go ahead and make it be a trigger at the moment. And then we're also going to add physics 2D rigid body, so it's going to have gravity attached. So its gravity scale will be, it needs to move faster than the jellyfish. They move at a gravity scale of 0.2 with a linear drag of 2. So the bullet should be, and this is just trial and error, let's have it be 0.4 with a linear drag of 1.5. So it's going to move faster and it should pick up momentum as it moves. So let's actually move that towards the top of the screen. Yeah, so that moves definitely faster. Again, balance issue. Let's go ahead and change that simulation space, but I'm pretty sure we're going to keep it as local because it looked like it broke it up a little bit too much. Yeah, not quite what I'm looking for. So we'll leave it as local. Alright, so now we have our bullet. It now has a collider. It now has a rigid body. So we'll take that bullet, we'll drag and drop that into our asset area, and now we have a prefab. So the last thing that we have to do is we need to have the enemies instantiated. Now here's the tricky part. You can't just have every enemy spamming these things out. I mean, yeah, there are bullet hell shooters, so you could do that, but even that you still need to have like a pause, like have they already shot? Can they have more than one shot at a time per enemy? Just like the player can only have 2 missiles out at a time. So balance takes a lot to make this work right. So it's not an absolute. You just have to come up with a control system. Generally speaking, the easiest control system is time. The other control system, since you have a bunch of enemies and they instantiate at the same time, you also have to have a random element. So there's a random element, there's a random number. If that number comes up within a certain range, then a certain enemy fires. So let's take a look to see what that would look like. So first thing we need to do is we need to make the jellyfish aware of the new bullet. So let's go into the enemy control, public, transform, bullet, obj. Now we'll click on, actually we already have it highlighted, take that bullet, drag and drop it. Now the enemy object is aware of the bullet object. So we could do a random number. So let's set aside a variable for that. So public int does it shoot? And we'll set this at 0. So, since we want this to keep occurring throughout, we want to have this be in the update section so it checks with every frame. So, actually, we should tie it to time as well. So let's put another variable in here. So we want it, if you tie it precisely to frame, then a slower frame rate would equal to less checks. So you really don't want to tie it to frame. So public. So you want it to check every frame to see if it's time to do it. So public float. Let's call this bullet timer. Set it to 0. Alright, so let's start with that bullet timer. We're going to add time.delta time. So if this is the first time you've seen that, what this means is that this runs once per frame, the update section. How much time has passed since the last time this frame has run and this line has been run. Take that amount of time, in other words the change in time, and add it to bullet timer. So bullet timer is a cumulative number. It is keeping a running cum of how much time has passed. So if bullet timer is greater than, say, 0.5, then we're going to do a bunch of things. Since we want this to happen every half a second, that's why it's 0.5, first thing we have to do is we have to set bullet timer back to 0, or else it'll only do it, well, it'll wait 5 seconds and then it'll keep doing over and over again. Second thing we want to do is we want to do does it shoot equals random dot range, and it ranges between 0 and 10, and this will probably be way too fast, but I want to make sure this is working. And now within this, if does it shoot is equal to, we'll say, 1. And really you can use any range. So if does it shoot is equal to 1, then we want to instantiate that new object, the bullet object. And the thing about the bullet object, is that it's kind of fire and forget. That the bullet already has a collider on it. The bullet already has a rigid body on it, so it already has velocity. So once the enemy shoots it, it really doesn't have to do anything else. The bullet will do the rest. The bullet will look for collisions. So instantiate the bullet object at the position of whatever the script is attached to, which is the enemy. So the enemy's position, and use the bullet object's rotation. And we're probably going to get too many bullets, but let's see if that works. Also, since all these enemies are instantiated at the very beginning, even the guys at the top might be shooting. So what probably happens, you're eventually going to get this rainfall of bullets. So you'd also want to check for the vertical location of the enemy. But again, this is just testing the basics. And I forgot to put in the equal sign as always. And one in here as well. See? And he shot. He shot. See what I mean about how it's starting to become a lot? Because the guys off the screen are shooting too. So, what we want to do is we'll reduce this then. So every half a second, well, a couple things. You can have the check less often, or you can have a greater random amount. So we could do, say, 2.5, or you can increase them both. Again, it's some of it's preference, some of it's exactly what you're trying to balance. Now, other questions: should you be able to shoot the enemy's shot? It wasn't intended, but because it has a slow start, it actually looks like it kind of queues up, like as if the monster is building it up. And again, we still have the rainfall. So let's put in that last check, and then I think that will wrap up this video. So we're checking for the bullet time. Alright, so what we're going to do here is, in addition to checking whether the range is right, we're also going to check if transform.position.y is less, and we said the top of the screen is around 5.5, so we'll say 5. So first, we're only doing this every 2.5 seconds. Every 2.5 seconds, we check for a number between 0 and 10. If it comes up to the number 1, and if the position of this object that the script is attached to, that's what this returns, transform.position.y. So the vertical position, the y position of the object this script is attached to is less than 5, then do the instantiation. So now we're probably going to have to alter this so it happens more often. Because now only these here. So he fired. He fired. Okay. So that's about it. I think that's enough, because any more than that and it really starts to get nitpicking. You really now have the sense of how you can manage. I wouldn't call this AI, but it's the very beginning of AI. You're making a decision set at when does the monster shoot the bullet. So you're basing it on time, you're basing it on random chance, you're basing it on location. So that's the very beginning of enemy AI when you get right down to it. Very rudimentary, but that's how it starts. Alright, so I hope you found this helpful.